Okay, we're in section 21 of the notes. We're going to do the examples. Again, hopefully you paid attention during lecture and that you're ready to see some more examples. We'll go through these examples. We'll do example number 1. We'll do example number 2. We'll do example number 3. We'll do example number 4. And then there'll be a chance for you to try on your own. Again, it's so important you start trying on your own. So let me go to the whiteboard. And I'll start doing one problem at a time. Hopefully they'll start with moderate difficulty and maybe move to something a little bit more challenging. So, this one over here, I want to just, sort of read it to you. It says a particle moves along a curve, y equals, the root of 1 plus x cubed. It says as it reaches the point 2,3, the y coordinate is increasing at a rate of 4 centimeters per second. How fast is the x coordinate of the point changing at that instant? So what do I claim over here? Just, kind of looking at it, and not that you have to draw a picture, you don't. I'm not saying you do. But the domain of this thing would start at -1. And then when you got to 0, it would be 1. So I can maybe say something like this over here. Again, I'm not saying this is a terribly accurate picture. Give me 1 second. It's not a terribly accurate picture, but it's enough for me to understand what the story is. And then they said at the point 2,3, well, 2,3 I'm going to say is over here somewhere. Now that's on the curve. And if you plug in 2, you'd get 8. 8 plus 1 is 9. The root of 9 is 3. So 2,3 seems reasonable. What does it say? It says at the point 2,3, the y coordinate is increasing. Now, I hope you realize that means it's going up at that point. So let me write down what the y coordinate is increasing. So dy dt is increasing at the rate of 4 centimeters per second. All right. Then they go on to say, how fast is the x coordinate of the point changing at that instant in time? And I hope you realize if it's moving up at that point, certainly d x dt would be moving to the right. So I certainly know it's a positive number. I don't know what the number is yet, though. So how do I do that? I write down the relationship. What's a relationship? Y equals 1 plus x cubed to the 1/2 power. I differentiate with respect to t. So d dt, the left side, d dt of the right side. See if we can do that. What do you get? Well, you get dy dt. That was easy. Then we go over here. You get 1/2, 1 plus x cubed. Well, let's see. You take away 1 from 1/2, you get -1/2. And the derivative of the inside is going to be 3x squared. And then what do you put down? Dx dt. Well, let's write down what we know. And what do we know? We know dy dt at that point in time is 4 centimeters per second. I'm not going to use the unit, though. 1/2. Do I know what the x is at that point? I sure do. It's 2. So it's going to be 1 plus, well, 2 cubed is 8. That's to the -1/2 times 3. And again, if x is 2, that would be 4. But I don't know dx dt yet. Let's see if we can do that. You get 4. This should be 1/2. Well, let's see. That'd be 1 plus 8 is 9. That's going to be 1/3 now. And then when you go over here, you get 3 times 4 dx dt. Well, let me see if I can do that. 3's cancel. I'm going to divide both sides by 4, multiply both sides by 2. So dx dt is 2. Now, what does that mean? 2 centimeters per second. All right. Now, granted, I realize some say, oh, it looks like a chicken scratch to me. We put all the work down here for you. Let's go to the next page. Make sure we get, we got the answer. And what does it say? 2. And what does that mean? 2 centimeters per second at that instant in time. All right. You may have to read over my work or simply say, I'm satisfied with your chicken scratch. All right. So this one, I realize that, this one's talking about a clock, and it says the minute hand on a clock is 8 centimeters long. I can kind of understand that. And it says the hour hand is 5 centimeters long. It says, how fast is the distance between the tips of the hands changing at 3 o'clock? Well, I'm going to draw a picture of that. And what I'm going to do over here is I'm going to draw, what 3 o'clock looks like to me on a clock. With the understanding of little hands over here, the minute hand would be exactly on the 12 mark, which is to be 8 centimeters long. And this over here would be 5. All right. Now, granted, this might seem difficult to you, but I want to point out the question they asked for is that the distance is changing over here. So the distance changing. And I hope you realize the distance is getting smaller. And why is that? The minute hand is actually moving much quicker than the hour hand. So what I'm going to do is I'm going to put the rate of the minute hand. And certainly I'm sure you've looked at clocks before, and it's kind of like annoying to look at it, but a minute hand, this is the minute hand, by the way. Its rate, and that's going to be a rotational velocity. It does 1 rev, right, every 60 minutes. All right. Now, by the way, we really probably shouldn't be using revolutions in mathematics. We should talk about the radian measure. And so it's going to be 2 pi every 60 minutes. That's once around, right? So what are you going to get there? Pi over 30 minutes. And that's the minute hands rate. Let's talk about the hour hands rate. So rate of hour hand. Hour hands move really slow. So an hour hand does 1 rev every 12 hours. That's 12 times 60 minutes, right? Well, I really shouldn't be using revolutions. I'll say 2 pi. That's going to be 12 times 60 minutes. I'm going to reduce that. And what do you get? You would get pi. Let's see pi, right? Because the 2 goes in. 6 times 6 is 360. By the way, I'd like to have the same denominator in both of them. And I guess the common denominator would be 360. Well, what times 30 would give you 360? That would be, let's see, 12, right? So 12 pi. Someone says, why'd you spend so much time doing that? And I'll tell you why. I need to find out how fast this is changing. And I hope you know that we're talking about d theta dt over here. Because this is my big interest is, how fast is theta changing? Well, I hope you know what's negative, that it's getting smaller. And what's the difference between these two guys over here? It would be 11 pi over 360. And again, the unit on the bottom is minute. All right. Again, you could use seconds, you could use hours, you could use days. But, maybe today I feel like minutes, another day I might feel like seconds, whatever. I don't know what my key says. So let's start talking about how d is related to theta. And again, I want to point out, this is theta over here. Theta is changing. How is d related to that theta? So I'm looking at it, and I'm going to say that there's a relationship. And I'm going to say, looks like the law of cosines. Now, where did you learn about the law of cosines? In Math 120. Let's see if that works out. So d squared equals 8 squared plus 5 squared minus 2 times 8 times 5 cosine theta. Now I have my relationship between d and theta. Now, by the way, on an exam, I want to point out it's so important that you start looking at work. All right. Now I notice that I put x down for the distance. Here I'm using d. Right. So let's take a look at this one over here. Did I get the relationship right? And what's the relationship going to be? Well, they used x for the distance. I used d. 8 squared, 5 squared minus 2 times 8 times 5 times cosine theta. Did I get the proper, d theta dt done? Minus 11 pi over 360 minutes. So I'm going to say these are two important milestones hitting the problem. Now what I'm going to do is I'm going to differentiate both sides with respect to time. So d dt, both sides of this equation. D dt, both sides of this equation. Now I realize what some students are saying. They're probably saying, why aren't you doing the arithmetic? Well, later I'll do it. Right now I'm just going to write this down. 2 times 8 times 5 times cosine theta And let's write this down. So what do I get? I would get 2d dd dt. Well, that's hard to say. And now I'm going to differentiate this side, and I get a bunch of zeros, 0, 0. And then what do you get? You would get, let's see, 80. I'm doing this over here, by the way. That would be 80 because, 2 times 5 is 10. 10 times 8 is 80. Sine theta. So dd dt. Oops, I forgot something. D theta dt. Sorry about that. I forgot that. So what are you going to do over here? I'm going to divide both sides by 2d. So what do you get? 40 sine theta over d theta dt. All right. So someone's going to say, what do you want to know? Well, I want to know dd dt. I want to know dd dt when the time is 3 p.m. You have to understand when the time is 3 p.m., the theta is actually pi over 2 or 90 degrees. So let me see if I can do that. So what do you get? 40. Well, I know theta, right? What's theta? That's going to be the sine of pi over 2. We'll do that later. But what's d at pi over 2? Well, I got to go up here and I got to figure it out. Let's put that down. So what's d squared at pi over 2? Let's write this down. 8 squared is 64 plus 25 minus 80 cosine pi over 2. Well, that's pretty simple because d squared, the cosine of pi over 2 is 0. So I get 64 and 25. That's going to be 89, right? I hope you realize d is a positive number. So d is going to be the root of 89. And that's at pi over 2. And pi over 2 again is 3 p.m. Let's go back over here. And what I find out, the root of 89. Now, what's d theta dt? I don't remember, but I have it written down. It's going to be minus 11 pi over 360. Let's put a unit on this. Remember, the minute hands are in centimeters, and my unit on that other guy is going to be in per minute. So centimeters per minute. And let's see if we can do it. And it looks nasty, I'll be honest with you. So I'm going to say, sine of pi over 2 is 1. And then I get, I guess I could do, this would be 10. This would be 90, right? I'm dividing through by 4. And 10 goes into 99 times, right? So what do you get? Sine of pi over 2 is 1. So you get minus 11 pi. We'll check the answer later. And then I get 9 root 89. No, I can't do root 89 in my head. I know it's between 9, it's around 9 though, and 10. But I'm not going to attempt to do that. Centimeters per minute. The distance is getting smaller. We were expecting that, by the way. So, mistakes happen. And I know for a lot of students, they often are concerned about that. I'm going to look at the key though, and I want to get there, right? And the key is going to be over here. And I'm going to copy it. By the way, they use an X and I use the T. And again, we're trying to teach checking. And I'm going to paste it over here. Give me a moment to do that. And I got it. Centimeters per minute. I got it. It's right over here. And again, what I mean, I got this over here. All right. What they do, they approximated it. That's fine. You need a computer to do that or a calculator. You can do that. We don't mind you doing that. All right. On exams, though, put the exact answers down. If it's web assigned or estimate approximate, use the calculator to do that. Don't struggle with that arithmetic. It's just a waste of time. So I'm going to say that was not too bad. I was able to do that. And you might be surprised what you're able to do when you start trying. Right. So let's put down number 3 now. And number 3 is a snowball. And so I know what a snowball is, and it says it melts. And it says the surface area decreases at a rate. So I'm gonna put that down, that it's a snowball. And I realize a snowball has a surface area, certainly. And they something about it. I'm gonna write this down for you. But again, if you're struggling with this, you can look the formulas up. So the area of a sphere is going to be 4 pi r squared. That's the area. When I mean area, the surface area of a sphere is going to be 4 pi r squared. Now, what do they say? They say if the snowball melts, its surface area decreases. So what they're saying is dA dt is decreasing, so it's a negative number. And what is it? 1 centimeter squared per minute. All right. Now they want to find the rate at which the diameter. So they want to know what's dd dt when the diameter is 10 centimeters. That's their question. I don't know the answer, by the way. But what I do know is I get trouble right away. My trouble is I know a formula for area that relates it to radius. So how's a radius? Well, radius is going to be what? Well, let's put this down. 2 times the radius would equal d. So what's the radius going to be equal to? D over 2. Well, let's write that down. So 4 pi, the radius is d over 2. So what do you get over there? You get pi d. All right, why is that? 2 squares. 2 squares of 4, 4 squares of 4 once, you get pi d. So what am I going to do over here? I'm going to write down A actually is related to D by this relationship over here. By the way, I'm sorry about that. I forgot to put D squared there. This is the relationship. Okay, so what are we going to do now? We need to do a derivative. We're going to take a derivative of both sides with respect to t. So d dt of the left side, and we're going to do d dt of the right side. What do you get? dA dt equals, what would that give me? That would give me 2 pi d dd dt. All right, do I know dA dt? I do. It's -1. We'll talk about the units later, by the way. 2 pi, well, my point of interest is at 10, where the d is 10. dd dt. Can I solve for dd dt? I think so. And what do you get? -1 over 20 pi. I hope you notice a unit on that. And the diameter is going to be centimeters. So it's going to be -1 over 20 pi. We'll check the key later. Centimeters. And what was the time unit? I got to look it up. It's minutes, centimeters per minute. Let's take a look at the answer and see if they got that. And they did, in fact, get that. All right. Now, at the bottom of the page, this hints is okay to look up geometry formulas. Where would you find those? Well, you guys, you can look it up on the internet if you want. You could look in a book. You could ask your neighbor. I don't know. Got to look it up somewhere, though, right? Hopefully a trustworthy source, by the way. All right. Let's look at this one over here. And again, when you're doing these things over here, you might say, well, I'm doing it differently than you. We want you to work on it, though. That's all we want you to do. So I'm going to kind of read through it. And what does it say? It says the two sides of a triangle are 4 meters and 5 meters in length. That's a pretty big triangle, isn't it? And the angle between them is increasing at a rate of 3.44 degrees per second. Find the rate at which the area of the triangle is increasing when the angle between the sides fixed is 60 degrees. Well, I'm going to try to ballpark the picture now. So I'm going to say there's a side that's 5 meters, and there's another side over here that's actually being rotated. How do I know it's being rotated? They tell me it's being rotated. It's increasing. Now it's around 60 degrees. So I'm going to say over here, this is the theta, and this is 4 meters over here. All right. So what do I know about this? They want to know about the area of it. So looking at it, I hope you realize that area has something to do with a formula. And I'll write down the area of a triangle. And there's many of them. I'm not saying it's the only one. There's other formulas for a triangle. So it's going to be 1/2 times the base times the height. All right. So I'm gonna put this in. This is the height. And by the way, this is the triangle we're talking about over here. All right. So let's write this down if we can do it. So what's the area going to be? It's going to be 1/2. Well, the base is fixed at 5. There's not much I can do about that. But what's the height going to be? Well, I'm going to write this down. And the sine of theta would equal that h. This is a right triangle. h over 4. So what's the height? It's going to be 4 sine theta. All right, let me simplify this guy over here. Area is going to be, let's see, 2 goes into 4 2 times. 2 times 5 is 10 sine theta. All right. All right, I got to do something here. I got to say, what did they give me? Well, they gave me some things. They told me that the angle theta, d theta dt, is increasing, which means a positive number, 3.44 degrees per second. Here's the deal, though. You can't use degrees in this problem here. You got to go to radian. So I'll write that down for you. And that's going to be pi over 180 degrees. Let me write this down. This is going to be 3.44 pi. The degree cancels off over 180. The unit on the bottom is going to be seconds. All right, that's d theta dt. What was our question, though? And again, if you don't remember, reread it. It says, how fast is the area increasing, right? How fast is the area increasing when the theta is 60 degrees? But realize this, I can't use 60 degrees. What is it going to be? Well, 60 degrees is going to be pi over 3. That's their question. So I need a relationship between a and theta, and I have it. It's right over here. What are you going to do? Differentiate both sides with respect to t. So dA dt is going to be 10 cosine theta d theta dt. Let's write this down. So dA dt, I'm going to write this down, 10 times cosine pi over 3. We'll do that later. Times d theta dt, and what's that? 3.44 pi over 180 per second. And what's the unit on area? It's going to be centimeters squared. Let me make sure they did use centimeters over here. Oh, I'm sorry, meters. I got centimeters in my head. I'll erase that, and I'll put down meters squared. All right, I'm going to do the arithmetic that I can do. So example, pi over 3 at 60 degrees. That would be 60 degrees would give me 1/2. So that's going to be 5 times 3.44 pi over 180. Let's see, 5 into 180, right? That's 36, isn't it? And again, it's meters squared per second. That's about the extent of my arithmetic, by the way. I get 3.44 pi over 36. No, I don't want to do that arithmetic. But I mean, just, I can't hurt to try. So let's see if I got the right answer. And, they put a decimal down over here. But let me just look at their work. And I have to be careful about it. And yeah, 10 times a half meters squared, 3.44180. Yeah, I see it over there. If you like, though, you can check this to make sure you get the same decimal over here. Okay, let's talk about this again. I know I sound like a broken record to a lot of students. This part over here is what you're studying. You study the prior material. The whole thing in studying the prior material, you should say something, I'm going to say something. When do I get a chance to try? You get a chance to try in the homework. You need to try the homework. You need to try that. How much time should you spend on that? Well, if you studied and understand what I've given you, the homework should go pretty quickly. It really should. It shouldn't be a long process. What takes a long time for a lot of students, though, is the study department. It's also the part where most students ignore. They say it's not important to study. It's more important to do a problem. And then they languish on problems and they can't do any of them because they haven't studied the material. And that's going to happen to you. It happens to everyone, by the way. Hopefully that's going to be a learning experience for you and you stop doing that. You need to study first and then do the homework. What are you going to study? What we presented in a lecture, and then the examples that we just did. Hopefully you paid attention. I know it seems like it goes fast. It does. This class goes fast. And your college educations will go fast as well, by the way. At least hopefully not languishing, doing the same thing over and over again. But anyway, if you need additional support after you've studied and did your best effort, please come by and see me.